In this video, we will solve a numerical example which appeared in GATE 2022 for Electronics and Communication Engineering subject. The question pertains to network theory and it is very good question which will cover some of the conceptual problems which we face during the study of network theory. Now let us see what is the numerical. Here we are told that there is a linear two-port network. Here we must understand that this linear word is very important, and this linear two-port network is shown in this figure A, where we have applied an ideal voltage source which is DC voltage source of 10 volt, and we are told that there is a variable resistance R which is connected to the port 2 of this linear network. So this is a variable resistance. Now what we are given? We are given that the voltage across this resistor and the current at this port 2 have been measured and they are plotted like this. Now here what we can see that when the voltage at port 2 across this these 2 points, voltage is 5 volt, then the current is 0 ampere. So the current entering into the network is 0 ampere. However, when this voltage is 4 volt, then the current entering is 4 milliampere, or this current actually it is given minus of I2. So the graph is between the current exiting the network, since minus of I2 will be in this direction. Okay. Now what we are asked that if we replace this network with the network given like this, that is a 10 volt source and a 1 kilo ohm resistor which is now connected across this. Now we are asked what will be the value of I2, that is the current entering inside the linear network. Now this question can be solved using Thevenin theorem. However, instead of doing that, first we will see how to find the Thevenin equivalent resistance and the Thevenin voltage equivalent for this linear network. Since the network is linear, then we can say that the voltage at these 2 points, this V2, can be represented as this equation, where V2 will be equal to A I2 plus B, where this A is a constant and B is also a constant. Okay. Now we can see this equation from various points also, like if I solve any linear network using nodal theorem or nodal equations, then we can see that any node equation, let us say this is a very simple network, that is some voltage source V1, this is some resistance R, and this is V2, and this is the ground, and this is R1, R2. Now we can see that if we want to see the value of V2, what we will do, we will solve it using nodal method, V2 minus V1 over R1 plus V2 over R2 is equal to 0. Okay. So on solving we will see that R2 into V2 minus R2 into V1 plus R1 V2 is equal to 0. Okay. Or we can see that this voltage V2 can be written as R2 V1 divided by R1 plus R2. So in this way we can see that this voltage can be written as like this, some constant into something plus some another constant which is 0 actually in our example. However, to generalize it further, I can write it like this. Now this constant, if I want to write that this is some current value, then this constant will be having the dimension of a resistance, And if I want to say that this constant is having nil dimension, that is no dimension, then it will be a voltage quantity in this equation. However, since I want to find the equivalent Thevenin network for the example or the question, what I will do, I will write the equation in this form for the voltage V2. Now this current I2 is the current which is entering into the network. Okay. Now we will put the various values. When I2 is equal to 0, that is minus of I2 or I2 is equal to 0, what is the value of V2? It is 5 volts. So we can see that 5 volt is equal to 0 plus B, or B is equal to 5 volts. Okay. Now let us see the next thing, where the value of I2 is minus 4 milliampere and the voltage is 4 volts. So I will write V2 is equal to 4 AI2 plus 5. Now I2 is equal to minus 4 milliampere. So 4 minus 5 is equal to minus 4 into 10 to the power minus 3 A. So from this we can see that A is equal to minus 1 over minus 4 into 10 to the power 3, or 250 ohm. So from this we have seen that this V2 can be represented as 5 volt plus 250 I2. Okay. Now let us try to interpret this equation. Now how to interpret this equation in the form of Thevenin theorem, that we will see in the next slide. In the previous slide we have reached up to this point. Now let us replace the given linear network from its equivalent Thevenin network. Now the equivalent Thevenin network will be having a voltage source whose value will be equal to the voltage which is equal to open voltage between the points, and a resistance which is equal to the Thevenin resistance of the linear network. And here the source will be connected, or this load will be connected. Now from this we can see that this voltage V2 is here and the current I2 is this current. Okay. Now if I want to see this equation and this network on comparison, we can see that what I can do, I can write this VOC, that is the voltage which will be there when I open the circuit, that is the current I2 is equal to 0. So when this I2 is equal to 0, the voltage V2 will be equal to 5 volts. So this V2 will be equal to the same voltage source. So now I can see that the value of this voltage source will be 5 volts. Okay. Now this thing I have got. Okay. Now the only remaining thing is the 250 ohm. Now this 250 ohm is the equivalent resistance which can be seen from these two terminals towards the network. So this resistance will be equal to the equivalent Thevenin resistance of the network. Okay. So now we have got the values of both the parameters, the R Thevenin and the V Thevenin. Now I can easily find the value of I2. So I2 will be equal to simply 10 minus 5 over 1 kilo ohm plus 250 ohms. So, or it is equal to 4 milliampere. So the answer which we will require to put in the response sheet will be 4.0 milliampere, and that will be the correct answer. So in this way we can see that there is a very general method to find the equivalent Thevenin network of any linear network given in the question. We just need to replace all the network which is there by just an open circuit voltage source and the equivalent Thevenin resistance, and we need to write the equation just by assuming that the voltage across these 2 points is there, let us say V volts, and it can be written in the form of some current and some constant, and this current should be the current entering the network from these 2 points. Now when I write the equation of the given network in this form, then this A will be equal to the R Thevenin and this B will be equal to the open circuit voltage of this network, which is the Thevenin voltage. So this is a very general method, and using this method we can solve any kind of question which will involve at least linear network in which Thevenin theorem is applicable. So if you find that this lecture is helpful to you, then please share and subscribe my YouTube channel. Thank you.